So we've used arrays before to store collections of like things. So I think the example I gave was maybe storing 6 lottery balls, and you can declare such an array like this. So we could say dim ball, we'll give it a name, and then inside the brackets we give it the highest index that we want to use. So that's the highest index rather than the length of the array. So 6 balls, I would put 5 in there because they'd be numbered 0 to 5. And then we have a type. So I would say as integer, for example, and then I could use that to store my 6 balls, each containing a lottery number. But sometimes it's useful, rather than a list of values, which that effectively is, to have a table of values. And we can create something called a two-dimensional array to store that. And two-dimensional array is quite often used for a lookup table. We'll have a look at how you can use that in a minute. But first of all, how we create it. So imagine I wanted a table that was maybe 4 columns wide and 3 columns tall. All I need to do is I put 2 indexes in there. Now the controversy comes with which way round you put them. So if I wanted 4 columns and 3 rows, I could either have them that way round, or I could have them the other way round. So if you get a GCSE question, if you're an A-level student as well, it will give you an example in the question of which way round, so you can see which way around they're doing it. But actually, it doesn't matter. So as long as you know what you're doing and you're consistent throughout your program, it doesn't matter which way around they are. So let's have a look at how we might start. So imagine we're going to start with creating just a table. We could jot this down. So we're all familiar with spreadsheets, hopefully. So imagine I wanted a table of cell names in a spreadsheet. So I'd have A1, B1, C1, and D1. And then I could go A2, B2, C2, D2, and then A3, B3, C3, and D3. So I would say that table is, well, it is 4 wide and 3 tall. Now, which way round I do my indexes is up to me, but I like to have the width first because I like to use the kind of XY notation that we'd use in maths. So if I was going to call this, if I was going to create an array of string variables called cell, I would go for 3, 2 because I would go for width first. But as long as you're consistent throughout your program, it doesn't actually matter. There's only one exception, which we'll have a look at in a moment. So I would say dim cell. So remember, the numbers in here are 1 less than the actual width because we can't start counting at 0. So I would go 3, 2. And then just like a one-dimensional string, with 2 dimensions, we say what the type is. So I'm going to make this string. Okay, so I can then use cell like I used an ordinary array, but I put 2 indexes inside the brackets. If I want to set a value, so I could do things like cell to 1, and that would set the value. Now notice, obviously, depending on which way round I decided my height and width were, that would give me a different result, and that's what I was talking about with the exam question. So when you come to do an exam, if we number these cells, so let's go, so vertically would be 0, 1, and 2, horizontally it would be 0, 1, 2, and 3. So in the exam question, they would always give you an example. So they might say cell 2, 1 equals, in my example, the way around I'm doing it, that would give you C2, wouldn't it? So it would be that one, 2, 1. If they were doing it the other way around, 2, 1 would be B3. So that's why they include that example there, so you can make sure which is which. So let's go back to my program. So how are we going to fill this in? So it would be a bit laborious to say cell 2, 1 equals, B3 and 0, 0 is A1, etc. So we can use loops like we did use loops for processing the one-dimensional array, only this time we'll obviously need 2. So we can use nested loops. So if I use X and Y, and that's why I like to have my rows first, because it kind of simplifies the visualization of the process, and we can use X and Y for the height and the width. So I'm going to say equals 0 to 3. So that'll count through my 4 columns. And then I'm going to say for Y equals 0 to 2, that'll give me my 3 rows. And then what I'm going to do on each for each value is I'm going to construct the value that goes in there. So I'm going to say cell x comma y. And if we do it like the example I just drew on the whiteboard, what's that going to look like? Well, we can use, if we take the number, so if I take x, and that's going to be 0 to start with, so it's going to be 0, 1, 2, or 3. So if I want that to represent A, B, C, or D, if I add 65 to that, I can then use that. That'll be the ASCII code then. So if I say CHR, that'll turn. So when X is 0, that'll be 65, and the character represented by 65 is A. And then for the second part, I'm just going to use the value of, well, not value of y, because that'd be 0, 1, or 2. So, but I'm going to use the value of y plus 1. So that should fill my array. If we wanted to check that it appeared correctly, so just go back to my whiteboard. So here, so let's pick out that value and see if it's appeared correctly. So I'm going to pick cell 2-1 and see if it's C2. So cell 2-1. So console dot write line cell 2-1. And if I run my program, it's going to set up that array, it's going to loop round, and it's going to fill in all the values, and then it's going to hopefully tell me what value is in 2-1, and it's C2, which matches my idea of what's going on in that table. So as long as you're confident that the height and the width, or the rows and the columns are the right way round, and you're consistent in the way you use that, it doesn't matter which way round they are. Okay, so that's one way of using a two-dimensional array. So I've looped through and I've put the values in. So you might remember that when we were creating a one-dimensional array, we could create the array and put the values in. So we can also do that with a two-dimensional array. So we need to declare it slightly differently. So this time we say dim cell equals, and then we say, rather than as, we say new string, and this time we put the dimensions in here. So I'm going to put 3, 2, and then we can use the curly brackets to indicate the values that are going to go in there. Now with a one-dimensional array, we could just do this kind of thing. We could have a comma-separated list of values, but obviously we can't really put a table of values on that single line. So what we do is we use two lots. We use nested curly brackets or braces. So this is where I said you need to be sure about which way round you go, because this case, each set of curly brackets represents a column, if you're thinking of it in the way round that I'm thinking of it, rather than a row. So I've got 5 columns, and then I can put the values in. So each one is going to have 3 values in it. So it's going to go, so going down the left hand column, it's going to be A1, A2, A3. So it'll be A, and they're strings, so A1, A2, and A3. Now this is a little bit more laborious if the numbers or the contents are in sequence, as mine are. However, we'll look at an example in a minute where that's not the case. So I can do a bit of copying and pasting, and so I'm just going to paste these in and just change the letters. So that's C, C, and C, and then D, D, and D. And in fact, I only had 4, didn't I? So I don't need that extra one. So let's get rid of that. And now hopefully, if I print out that value that we had before, so it was 2-1, wasn't it? And we're looking for C2. So let's, on the next row, so that, you get quite a long row there, but so if we have print, not print, we have console dot write line, and we're going to have cell 2-1, and that's going to hopefully gives C2 in the same way. So we can set the whole array and give its contents like that in one go. Doesn't make much sense. It's probably a little bit easier to use the arrays to fill that up because they're in sequence. However, what about if it's something else? If it's a game of results or something. So you might be familiar with the game Rock, Paper and Scissors. So let's have a look at how you can use a two-dimensional array to decide who's won in the game of Rock, Paper and Scissors. So what we're going to do is we're going to use an integer to represent. So we'll have 0 for rock, 1 for paper and 2 for scissors. And we're going to, if we have a little table, so you imagine you're going to play the computer. So we'll have the PCs go across the top and the users go down the side. So the user can pick rock, paper or scissors, and obviously the computer can choose rock, paper or scissors. But we need to decide who's going to win. So we can use this table to look up the winner. So for example, if the PC chooses 0, which is rock, and we choose 1, which is paper, who's won? So we know that. So if we just undo that. So if the PC chooses rock, what I'm going to do is I'm going to pick a point of view. So I'm going to pick the user's point of view. So we know if they're both the same, it's a draw. So what I'm also going to do is think of a way of coding those results. So I'm going to have maybe -1 for losing, 0 for drawing, and 1 for a win. So from my point of view there, it's a positive thing to win. So I'm going to have 1 to represent a win, and that's there we go. So we know that where both pick the same, it's going to be a draw. So we can fill in our table like so. If the user picks 1, which is paper, and the computer picks rock, which is 0, then I win. If I pick 2, which is scissors, and the computer picks rock, then I lose. And we can fill in the rest of the table like that. So if I pick rock and the computer picks paper, then the computer wins and I lose. And then actually once you started filling in the table, we can see that obviously on each row there's going to be a win, loss and a draw. So we can quickly fill in the rest of that. Okay, so what we're going to do is we're going to put those results into an array, a two-dimensional array. However, we need to remember that when we're putting them in like that, we're putting them in a column at a time, like so. So we're going to have first column, second column, third column. So going back to Visual Studio to put that in. So what I'm going to do is I'm going to say, I'm going to call it dim result equals, and then I'm going to say new. So it's just an integer, isn't it? So in fact, we probably get away with a byte. And then what we do in here is we give the dimensions. Now the dimensions, it's a square table, isn't it? So it's going to be 0, 1 or 2. So it's going to be 2, 2. And then we're going to put the values in here. So we're going to have 1, 2, 3 columns. And just using those same values off the whiteboard, which I jotted down. So it's going to be 0, 1, -1. The second column was -1, 0 and 1. And the third column was 1, -1 and 0. So we need a few other things, don't we? So we need maybe something to tell us what each of the numbers represents. So we're going to say dim. Well, what we'll have is we need the outcome as well, don't we? So outcome equals new. So this is going to be a string. So there's 3 outcomes, and what those outcomes are in the same order. So we said -1. So this is going to be used to look up the text equivalent of the result. So from our array here, if I say 0, it's going to be a loss. a draw. 1 will be a win, and -1 will be a loss. So what I'm going to do is I'm going to add one of those, so it goes 0, 1, and 2, rather than -1, 0, and 1. But I thought, in terms of the array itself, using positive and negative for winning and losing seemed a better way to do it. So I'm going to stick these in a one-dimensional array. So I'm going to have lose is the smallest number, draw in the middle, and then win. So I'm using a combination of one-dimensional arrays to look up and two-dimensional arrays. So what we need to do then is we'll say dim, so we'll have user and PC as, well, they can be bytes as well. So we're going to ask the user for their go. So we're going to say, and then we'll also generate the PC's go using a random number. So I'm going to stick in randomize at the top. And so we're going to say user. So let's prompt them. So console.write, and just remind them which way around it is. So 0, so 0 for rock, 1 for paper, 2 for scissors. And then obviously if I was doing this for real, I would validate that a bit more and make it look a bit nicer. So then I'm going to say the user's go is console.readLine, and then the PC's go is PC equals, so there's another separate video on scaling random numbers, but basically I'm going to go random number, if I can type properly, random number multiplied by the number of options we want, so which is 3 options, 0, 1, or 2, and then we're going to round that off. So we're going to use int to round that down. So we've got 2 values there. What we want to now know is who's won. So we're going to use the user and the PC values to look up that value from a table. So the actual result, so which means whether the user has won or lost, is so result will take user PC, and then we'll turn that, so that will give a 0, -1, or +1. So we'll add 1 to that, and then we'll use that to look up the outcome. So -1, 0, or +1 becomes 0, 1, or 2, which we can then use to look up from the outcome array, and we'll display that using a write line. So hopefully that's enough brackets. So let's just run that. There's an error, so what's wrong with that? So 1, 2, 3, 1, 2, 3. Looks like the right number of brackets there. Doesn't like my use of byte. Okay, so if I say rock, it's going to tell me it's a draw. Now, as it stands, we don't know what each thing is. So let's just print those out so we can see. So let's say console.writeLine. So we'll have you chose that, and then what we're going to pop in there is we're going to pop in well, actually we need some more things, don't we? So we say dim thing equals new string, and then, well, we don't need the index in there, but we'll stick it in. And then we're going to say rock, paper, scissors. Okay, so you chose thing, user, and then we'll have another line, basically the same. So the computer chose thing PC, and then we'll have we'll just leave that as it is. So let's see now. So if I say rock this time, it'll say I choose rock, the computer chose rock, it's a draw. So let's try that again. So let's go for, I'll go for paper this time. So I chose paper, the computer chose rock, and I've lost. So what this is telling me actually is I've probably got them the wrong way round. So what I'm going to do is I'm just going to come here and I'm going to go for PC user. Okay, so it can get a little bit confusing with all the rows and columns. So just be a little bit careful that you've got them the right way around. Let's try that again. So I'm going to go for rock, and the computer chose paper, so I've lost. Let's try that again. So obviously we could repeat this in a loop. So I'm going to go for scissors this time. So I chose scissors, the computer chose scissors, it's a draw. And so let's go for paper. So I chose paper, the computer chose paper, it's a draw. Let's see if we can get a different result. So I'm going to go for rock. We both chose rock. Okay. So I'll go for scissors. There we go. So I've lost. So that's right, isn't it? That's the right way around this time. So let's just try one more, see if I can actually win. No, I've lost again. So I'm not doing very well here. Oh, there we go. I've actually won. So I chose rock. The computer chose scissors. Rock beats scissors. So I've won. So we can see that apart from getting the rows and the columns the wrong way around, which was easily spotted and corrected, what I'm doing is I'm using this table that we've created on the whiteboard to create myself a little lookup table, and I've used the two values, my guess and the PC's choice, to look up in 2 dimensions from the table who wins, and then I've used a single dimension array to turn that number into some text which I can display on the screen. So I've used that table to produce my result.